So today we're going to look at slope of a line segment. So I'm on page 519 in your workbook, and let's take a look at this little introduction piece. So it talks about a trucker driving up a hill with a heavy load, and they're probably going to be concerned with how steep the hill is, not only going up, but certainly going down as well. Builder for a roof might be concerned with the steepness, or otherwise known as the pitch of the roof. A skier going down a hill might also be concerned with how steep the ski hill is. And so the term slope is a mathematical term, and we use that to describe, it's a measure of how steep a line is. Okay, and so if we take a look, we are looking at slope specifically as a ratio of the rise, so the change in the vertical height compared to its run, so the change in the horizontal distance. So we would say then that the slope is equal to rise over run. And we would say the rise is positive if we count up to the right and negative if we count down. So if we take a look, so generally speaking, anything going this way is considered a positive slope. Anything going this way, down and to the right or up to the left, that is considered a negative slope. Okay, so let's take a look then. And so just to give you a sense of slope as well. So if I wanted, I'm just going to borrow a little part of this grid right here. If I wanted to go up, let's say 4 units, and let's say I'm starting right here. If I wanted to go up 4, if I went up 4 units, but I did that over a longer period. So let's say right here, I'm going up 4 units, but over this run of 6 units, this is one slope. Comparatively, if I went up the same height, but went at it over a run of only 3 units, we can see that it is steeper when the run is shorter, right? Same thing, if we put it directly above, then this slope is incredibly steep. Certainly would not want to be skiing or driving on something like that. And so that's why we're looking at not just the top to bottom, that measure, but that measure over what kind of a distance. And those of you who have done outdoor education and you're backpacking, hiking, we know that we have a certain elevation gain, but sometimes it's easier for us if we gain that elevation over a longer distance as opposed to just going straight up, and thus creates the switchbacks that you often see on trails. So let's take a look then. If we take a look at line segment AB, we are to the right, we are going to go rise of 2, so we're going up 2, and then over how many units? 1, 2, 3, 4, 5, 6, 7. So the rise is 2, the run is over 7, and so the slope is rise over run, so it's 2 up for every 7 over. Okay, so hit pause, try C and D for yourself, and then come back and let's compare. Okay, so let's take a look. So if you take a look at CD, so we can look at it in 2 different ways. So if I'm looking from left to right, to go from D to C, I would go up 5, that's a rise of 5, and then over 4 units, so 5 over 4. Alternatively, you might say, well, wait a second, why don't I go from C to D? Fair enough, in which case we'd be going down 5, which would then be -5 as your rise, and then your run to go from here over to the left is then -4. So that's why that would still be equivalent. If I'm looking at EF, so again, going from left to right or from E to F. My rise, I'm going down 5, so that's why that is -5, and then to the right 3, so that's why my slope is -5/3. Okay, and so again, you can see CD and AB are both going up to the right, so that's why those slopes are positive. From E to F, we're going down to the right or up to the left, and that's why that is a negative slope. Okay, so let's take a look. This is a great chance to take a look at how we can build our investigative skills. So looking at points A, B, C, and D on this dot chart with this line segment. And so we're just looking at different parts of this line segment. So would you please work through investigation number 1, looking at rise and run and slope of all of those different portions, and we'll come back and discuss. Okay, so hopefully you've filled everything in and counted rise over run for each of them, and what you hopefully would have figured out, and even just by looking at it, it makes sense that all of the slopes are equal. So imagining that you are driving along this pitch or walking, hiking, or skiing, that is one continuous slope, and that rate of change of rise over run is the same regardless of which section we look at. Okay, so, and there it is right now. The slopes of all line segments on a line are in fact equal. So if I wanted to find the slope of line AD, I could actually just go ahead and count line segment AB or CD, knowing that the whole thing is going to have the same slope, because you can see all these dots and it just gets a little confusing to count all of those. But if I know that the slope of the whole thing is going to be the same, why not just take a look at the slope of this portion, and we know it will then be the same. Okay, let's take a look at investigation number 2. So on grid 1, we have some horizontal lines, and grid 2, we have vertical lines. So would you please take a moment and figure out what the slopes of each of those line segments are, and then come back. Okay, so what do we notice when we look at slope being rise over run in grid 1 with all of our horizontal lines? Our rise is actually 0 because we're not going up at all, we're just going a horizontal distance. And so when we take a look at those slopes, it's 0/8 or 0/11, 0/5, and in every case, 0 divided by anything other than 0, 0 divided by 8, 0 divided by 11, 0 divided by 5 is 0. So the slope is 0, and that makes sense, because if we say, well, how steep is it? Well, if it's flat, it's not steep at all. So that's why the slope is 0. Whereas we take a look at the vertical lines, we would have 10/0, 7/0, 13/0, and we cannot divide by 0, so it is considered undefined. So all horizontal line segments have a slope of 0, and vertical line segments have an undefined slope. Let's take a look at investigation number 3, and so that's taking a closer look at positive and negative slopes. And so in this particular case, if I was looking at line 1, first thing that I often go to are the endpoints, but wait a second, that's super unhelpful, because those endpoints are not going through any integer values, which would end up meaning that we're going to try to estimate, which is never good to do. And so what we're going to scan for, and what you can see that it actually states, is that each of the lines on the grids passes through at least 2 points with integer coordinates. And so we're reminded of that previous investigation where we saw that all portions of the line have the same slope as the line itself. And so if we scan through here, and it looks to me like I can take a point right here and right here that are going through integer coordinates. So we'll take out this endpoint because that's not useful. And so if I look at line 1, remembering that anytime if we are counting up, it's going positive. If we're counting right, it is also positive. And if we go down or left, then that is negative. So if I decide to start on the left point here, I'm going up 2, so rise of positive 2, and then a run of positive 3. So for line 1, rise over run is going to be 2 over 3. Okay, if we take a look at line 2, again, endpoints, so unhelpful. So let's scan for some integer points. So that looks like 1, and nope, nope, nope. Oh, there we go. Okay, and so if we find the slope of those 2 points, or between those 2 points, then we have the slope of the whole line. So again, going from the bottom here, so if I go to if I count up for rise, that's 1, 2, 3, 4, 5 up, and 2 to the right. So it's rise of 5 for a run of 2. And let's take a look at line 3. We are looking at this point perhaps and this point. So we have a rise of 1 and a run of 3. So then rise over run is 1/3. So you can see sometimes we're getting improper fractions, other times we get proper fractions, and that doesn't matter. We will never change to a mixed number, and we won't worry about it being a decimal. So it gives us the most information when it is a fraction, because we know the numerator has to do with the rise, the change, the vertical change, and the denominator is the horizontal change. So would you take a moment and work through lines 4, 5, and 6, please? Okay, and so what do we notice then? We found the points on those lines, and we found that the slopes are -2/3, -5/2, and -1/3 then. And it, typically speaking, we like to leave either the negative out front or with the numerator. It's okay to say that it's 2 over -3. It's the same value as if it was -2 over +3. So it's up to you how you want to write it, but usually we like having that negative out front or up top. Okay, so what I'm saying is we could also write -2 over 3, could also write 2 over -3, and they all refer to the same slope, the same value. Okay, when we compare the lines of 1 and 4, 2 and 5, and 3 and 6, we can see that they are the same steepness. However, one is positive and one is negative, and so it's just depending on which direction they're going then. So they're same level of steepness. Okay, so it's just like going off one side of the mountain or off the other side of the mountain. So it's just a different direction. Okay, so a line which rises from left to right, so left to right, has a positive slope, and a line which falls from left to right, so left to right, and it falls going down, then that has a negative slope. Okay, so let's take a look at this one then. A grid has been superimposed on our sketch, and we want to estimate the slope of the roof to the right of the worker's head. So what we want to do is try to identify some points on that roof line, and so take a moment and see if you can find a couple of points that look like they're going through integer coordinates. So I've got one there and maybe one here. Okay, does that look reasonable? Okay, and so if that's the case, we don't have to go from endpoint to endpoint. And so when we look at that, then the rise is just 1. Okay, so from here to here, so we've got a rise of 1 and a run of 3. So I'm going up and to the right. So that's why they're both positive. We can also see that the line is going up and to the right. So my estimate would be positive 1/3 for my slope. Okay. So could the grid be used to estimate the pitch of the roof the worker is standing on? Okay, and we're talking about this one right here. So take a moment and have a look, and and then we'll talk about it. Okay, so what do you think about that? Is it possible to find a couple of points? Possibly. I think what we need to consider is the perspective that we have. No different than if we're looking at this pitch right here. That's a little bit different as well because of the angle of this diagram. It makes it difficult and thus could cause some inaccuracies. Okay, so we could say that it is difficult, okay, given the angle of the perspective. Okay, so your viewing angle, if that makes sense. So let's take a look then at class example number 3. So let's draw a line segment on the grid, and it's going to pass through the point -4, 2 and have a slope of -2/3. The line segment must be long enough to cross both axes, and write the coordinates of three other points on the line segment which have integer coordinates. So what do we know? We could have infinite possibilities that have just the slope. However, there's only one line that passes through -4, 2. So let's find -4. So we go x-axis first and then 2. So it has to go through that point. We can see that the slope is negative. So we know that it is sloping down to the right, and it is totally up to you if you want the negative to go with the 2 or the 3. So let's say that we say -2/3 is the same as -2/3. So that means that we have a rise of -2. So I'm going down 2 and then to the right 3. There's a point right there. So that is -1, 0. And then keep finding additional points. So down -2 from there and run of 3. There it is. And that is at 2, -2. Another point, down 2 and right 3, and that is at 5, -4. So that's often the direction that students go. However, we know that the line could also be going down to the right or up to the left. So I could instead also think of this as 2 over -3, which means that I rise 2 and run left 3. And there's another point. And so then we can take a ruler or a straight edge, and ideally we are going all the way through and drawing it right through all of those points then. And extending that. Perfect. Okay, great. So if a line segment has a slope of -5/7 and the rise is 12, calculate the run as an exact value. So we know the slope as -5/7, and so this kind of brings us back to, let's go back. Where are we? Oh, right back here. So notice how I might have a slope of 2/3, but it can be expressed as equivalent fractions, equivalent ratios right there. So depending on what we're counting. So 5/7 or -5/7 might actually be reduced. So because we know that it's rise over run, and I'm also going to give you a heads up that slope is using the variable m, and so we know that that is -5/7, or it could also be 5 over negative 7. And what do we know is the rise is 12. So the rise, that is our numerator. And so we're just trying to find our denominator. Since the rise is positive 12, then this negative 5/7, that's probably not the best one to use. And we'll stick with this ratio right here. And there we have it. It's an equivalent fraction that you can then solve. Okay, so take a moment and hit pause if you want to try going through it yourself. Otherwise, we'll go through it together. Okay, so it's a ratio to solve, so a number of ways to go through this. So some of you maybe are treating this like an equivalent fraction. So you're saying 5 times what equals 12, and you're going to multiply the same thing by negative 7. That will certainly work. The other way is to solve algebraically. So if I have 5 over negative 7, I do not love that x in the denominator, so I can go ahead and multiply both sides by x, or x over 1. And the nice thing about that is x over x is 1, so that goes away. So we have then 12 is equal to 5x over negative 7. So now we will multiply both sides by negative 7 over 1, multiply by negative 7. And so now we have 5x is equal to negative 84. And last step then is to divide both sides by 5, and x is equal to negative, that is 16.8. So that gives us our run. So the run is, as an exact value, negative 16.8. Okay, great. So let me know if you have questions, and please complete the assigned work.